the Paposia Anglers support and help out with. So if you're interested in joining the Paposia Anglers, please see Peter back there and sign up. We'd love to have you. All right, so the first thing I'm going to talk about today is our public fishing access area on the Little Paposia River. It's a short drive south of town on Red Canyon Road. In my opinion, it's one of the most underutilized public fishing areas we have in the area. It's really good. The fishing around Lander's really good too, but there's a lot less pressure here. So it's about a 2-mile stretch of a river, and we sample it every 5 to 7 years, doing what we call a depletion population estimate. So we'll electrofish the same reach 3 times. Each time we take all of the trout that we catch out, we hold them in live cages, and we can figure out the pounds and number of trout per mile based on the number of fish we catch on the first pass versus the second versus the third pass. As you can see, it takes a lot of people. This is something the Paposia Anglers helped with last year. So the take-home point here is that trout numbers are really high there. So that graph there, that shows the pounds of trout per mile. So you have year on the horizontal axis and pounds of trout per mile on the vertical axis. So we have a good 50-year data set there. And 2024, again, our highest biomass in about 20 years. I can explain some of those variations in trout biomass there. So in the 90s, we had a lot of good water years, and that creates good fish habitat. In the early 2000s, we had an extended drought, so that took a toll on the trout population after a while. But in recent years, we've had higher water years, better trout habitat. Another thing to mention is whirling disease. So we found whirling disease in the Paposia watershed in the mid-1990s. So prior to that, the vast majority of the fish that we captured were all rainbow trout, not all, but most. And since whirling disease, rainbow trout numbers have gone way down, but brown trout have taken their place. So here's our numbers. This is the number of fish we caught during those 2 days of electrofishing. You can see over 1,200 brown trout, only 88 rainbow trout, and that's the most rainbow trout we've caught in about 20 years. So it's still not a lot, but at least the most we've seen in a while. Also mountain whitefish, they're a really cool native species. There's some pretty big whitefish in that section of river. So I mentioned brown trout. There's some pictures of some of the nice brown trout that we caught. And mountain whitefish there on the right, and that was one of the biggest rainbow trout that we caught. There's definitely bigger rainbow trout other places in the watershed, but this section doesn't really have a lot of big rainbows. I guess, does anybody have any questions on the Little Paposia? Andrea?
Are brown trout native to Wyoming?
No, brown trout aren't even native to North America. They're native to Europe.
Okay. And rainbow trout also are native, correct?
Rainbow trout are native to the west coast of North America, but they're not native to Wyoming. All right. So the next multitude of slides, both Jake and I are going to talk about some hooking injury studies that we have going on. So this was kind of kick-started about maybe 5-6 years ago. In the North Platte drainage, our Casper Fisheries management crews started noticing that most of the trout that they're catching during their sampling had hooking scars and hooking injuries. And they found that the higher prevalence of hooking injuries and the higher magnitude of hooking injuries, fish condition decreased, and it also affected fecundity, or the number of eggs a female can lay. So based on what our Casper crew found, all the fisheries crews around the state have been looking at hooking injuries in their major trout fisheries, because this is actually something we can manage. We can go with tackle restrictions only if necessary to maybe try to limit some of our hooking injuries. So we classify hooking injuries. We have a 5-level scale. So a 0 means no hooking injury. A number 1 is a minor hooking injury. So most of you probably can't see that. It's a really small cut on the upper lip of the trout there in the red circle. That's a minor hooking injury probably is not affecting the fish much.
What would the timeline be? Like, how long ago would you guess that fish was hooked?
Boy, I mean, it's hard to say.
Okay.
You know,
Like, caught that morning or like a week?
I honestly can't say. It, it just depends on the magnitude or the, how, I guess I just don't know.
There. It's a good day.
But so number two, this is a moderate hooking injury. So you can see there's some trauma to the face, some scar. It could be infected, it could be healed over, but basically it's something that we think might be affecting the fish's ability to feed. Then we have number three, that's what we call a severe injury. So what we classify as a severe injury is the fish can't completely close its mouth. It definitely affects the fish feeding. And then we get the massive injuries, and that's where the fish definitely can't close its mouth. It definitely affects the fish's feeding and probably reduces the survival of the fish. So just keep those scales in mind when we talk about some of our hooking injuries in the upcoming slides. So now I'm going to go back to the little Paposia, and we have good news for the little Paposia. 93% of our trout had no injuries, and we also had none of the massive injuries. Now if you compare that to what the fish management crew at Casper found, 61.5% of their fish had some sort of injury, and 20% of those injuries were massive. So we concluded that right now hooking injuries are having little impact on our little Paposia fishery. We're going to keep looking at our other trout fisheries. This coming year I'll be electrofishing the North Fork Paposia, the North Second Fishing Axis, and we'll just keep evaluating our fisheries as we keep going on through the years. With that, I'm going to turn it over to Jake. Oh yeah, sorry, question. Sorry, Andrea, go ahead.
Do hooking injuries occur even if you crunch the barb? It's barbless hook.
So barbless, hooking injuries can occur without a barb, but definitely less often. So I guess something I forgot to mention, and I'm glad you asked that question. So some of the implications in Caspers, they're changing their regulations starting in 2026. They're going to go with single barbless hooks in a lot of areas. Another thing that's really common in the North Platte River drainage is they use it's called pegged beads. So they actually there's no hooks on the beads, but they tie the beads to their fishing line, and then you have a trailing hook, maybe like 4 or 5 inches below the beads. So the trout will go to hit the bead, and then the angler sets the hook and it snags him in the side of the face. And in the future, we're going to consider that snagging in the Casper region. That's not going to be legal. So, but yeah, barbless hooks definitely help reduce hooking injuries. Any other questions?
All right, so a little different story on the Wiggins Fork stuff. Wiggins Fork is really popular. East Fork drainage in general is really popular, but the Wiggins kind of top to bottom gets fished a lot. So we did 3 sites in 2024. We do kind of a top to bottom approach so we can see the system across its entirety. So we have an upper site all the way up at Double Cabin. Then we've got Black Mountain in the middle, and then we've got the ship in place at the bottom, which is right near the East Fork confluence. So relative abundances were highest at the Double Cabin site, which makes sense, more pristine habitat up there generally. And they were lowest at Black Mountain, which was kind of interesting. We generally expect abundances to decrease as we lose some of that good habitat further downstream. So we again looked at hooking injury, and it was high in the Wiggins Fork. Before I get into this, the caveat is that we have really small sample sizes. So, with the little Paposia, we're talking 100 some fish. With the Wiggins, we're talking 20 fish. So it's tough to make a huge evaluation based on that. But anyways, so 68.2% of fish were injured at the Double Cabin station, and that's any injury, so 1 through 4. 78.6% were injured at the Black Mountain Station, and again, 1 through 4. So, again, some caveats there is that the entire East Fork drainage has a special regulation where cutthroat have a mandated release, whereas other species don't. So that may be artificially inflated there because they might get caught 5 times and they have to be put back. Whereas a brown trout that was caught might just get caught and harvested, right? So we might not actually be seeing injury rates across all those species as accurately as we'd like. And again, those sample sizes are limited, so 22 fish at Double Cabin, 14 fish at Black Mountain. And similar to what Paul talked about, we have these on a 3-year rotation in the East Fork. So this year we'll do the East Fork proper and then the main stem Wind River as well. And then the Wiggins will be back on the schedule 3 years from now. So something to monitor. Like Paul said, there's regulations we can implement to help with that a little bit. We know there's a fair amount of guiding that happens up on the Wiggins, but yeah, at this point in time, it's just kind of evaluate, build our sample sizes, and see if we can build a better data set before we make any decisions. So the other big point I want to drive home here is that this same hooking injury study was done in 2022 on the main stem wind, and there was only a 1% injury rate in that. So this is all of the different sites across the state where this study was conducted. So if you look over here on the left, you've got a lot of the Casper region waters, Miracle Mile, 70+% of fish injured. Gray Reef, After Bay, pushing 90% of fish injured. And then obviously over here in the Lander region, we've got the lowest in that figure of percent injured fish. So it really varies depending on the water. Anyone who's kind of been around the area for a while knows that Double Cabin is a destination. People love to go there, set up camp. Those fish are just going to have a higher injury rate as part of that. Whereas the main stem wind doesn't get fished as much, so definitely varies by water. So any questions on Wiggins Fork stuff before I turn it to Caroline? Yeah.
Jason, have you guys looked at levels of hybridization up there?
Between cuts and rainbows? Yeah, so we don't see a ton up there. In the East Fork itself, we see a little bit, but we, for whatever reason, don't see a ton of rainbow trout in the Wiggins Fork, or Bear Creek for that matter. I think in the last sampling event there, we only caught 1 rainbow trout at the lowest site in the Wiggins, so we don't see a ton of it. What we see more of in the East Fork is the Snake River phenotype, rather than what we call the Yellowstone phenotype. Genetically, they're both kind of one and the same, fine spotted versus large spotted, but as we're learning more, not to get too far into the weeds, but as we're learning more on the genetics, that's what we see more of, is just a Snake River heritage in that East Fork drainage rather than Yellowstone. Anything else? Okay.
All right, so like I said, I'm a fisheries tech here in Lander. I'm starting my 2nd season, and so last year had the opportunity to pursue kind of a side project and decided to, with Paul and Jake, to look at tiger trout in some of our higher elevation lakes. Tiger trout are a relatively new hybrid species. They are a sterile hybrid between a female brown trout and a male brook trout. So creating a hybrid in our hatcheries and rearing them is generally more time intensive and expensive, so we thought it would be important to look at our tiger trout in these lakes, particularly since there's little information about these fish in higher elevations. So from the literature, tiger trout tend to perform best in waters with abundant fish to eat. So with that in mind, we looked at 3 different lakes, and they were stocked in 3 different lakes near Lander. So here's a map. I know some of you can't see it, but just to orient ourselves, our first lake is Smith Lake in the Kaposia drainage. It's about 6 miles round trip to get there. Upper Silas, same story there in the Little Kaposia drainage, And then we have Cow Lake, which is just off the Loop Road. It's just like a quarter-mile walk from the road, so relatively accessible and a popular spot for folks. So our objectives in looking at the tiger trout fishery, again, looking at these 3 different lakes in the area, were to see if tiger trout are meeting management objectives, and those management objectives vary, but in general, they are a length objective, so how big we want those fish to be, and then how many we're catching, whether it's by angling or when we set our nets, just to see if the fish are there and if they're the size we want. The second thing we looked at is how fast are tiger trout growing and what are tiger trout eating, both things that are important to look at when we're evaluating this fishery. There we go. So we're going to start with Cow Lake. Like I said, pretty accessible right off the Loop Road. Historically stocked with brook trout, and those brook trout did get relatively large if they could survive the winter. So we tried tiger trout in there starting in 2015, stocking them biannually. And our goal there was really just to create a quality tiger trout fishery. It is a popular angling spot, so it provides a new and exciting opportunity for folks to fish there, and there are also abundant lake trout there, so potential food for those tiger trout to eat. And ultimately, in a netting event in 2022, we found the average length of our tiger trout there was actually over 20 inches. You can see it brought out some really nice fish. Exciting to catch a fish that big in a lake or a pond. I mean, it's less than 5 acres. So it really did prove that it could provide a quality tiger trout fishery. Unfortunately, it winter killed in 22-23, so all of our tiger trout in there did die, which happens. But as of 2024, we've restocked. We'll continue to stock that lake. And again, ultimately, we know it can be a great tiger trout fishery. So overall exciting results there despite winter killing. And again, tiger trout met the management objective there in terms of length and how many we were catching in our nets.
I have a question.
Yeah.
How deep is Cow Lake? Is it big winter kill?
Yeah, so Cow Lake max, I believe, is 19 feet. And I would even say that it might be a little bit shallower than that. If you've been there and you've been out, like I went out on my paddleboard, kind of look at the vegetation, there are rooted plants that grow from top to bottom, so it's shallow. It's a pretty shallow lake. So at Smith Lake, historically had lake trout that was maintained through natural reproduction. Whether it was through illegal introduction, a bait bucket, something, long-nosed suckers ended up in there, which aren't entirely desirable. So we thought stocking tiger trout in Smith Lake, they could really take advantage of that long-nosed sucker population. So our goal there was to put the tiger trout in and decrease the sucker abundance. So graph here, we have our abundance of long-nosed sucker in 2001 versus 2024, as well as a size range. So the ultimate take home here is that in 2024, which is 10 years post tiger trout stocking, we have more long-nosed sucker, and it appears that they are larger. So it does not appear that our tiger trout at this point are taking advantage of that food source. And in addition, we did not hit our catch rates or our length management objectives here. So overall, we just saw that tiger trout were not growing as desired here. In Upper Silas Lake, there is a brook trout population there, historically a bit stunted, so not growing as large as we had hoped. So we put tiger trout in, hoping to decrease that brook trout abundance and ultimately shift the size structure to larger fish. So looking at our catch per unit effort, or how many fish we're catching in those nets when we set them, we can see that there is a little bit of a spike. There's a little bit of a spike here in 2022, and then it drops back in 2024, kind of to where it was pre-tiger trout. But ultimately, this trend line shows that brook trout abundance is overall increasing, and again, it doesn't appear that our tiger trout are having much effect on the abundance of our brook trout. And then here, this is a figure of the size structure of our brook trout, again by year across these 4 netting events, and ultimately we see very little change in our brook trout size structure. Our biggest brook trout we captured in nets was 11.1 inches, and we caught one in 2011 and in 2024. So really little change there. In terms of catch per unit effort of tiger trout, they are there. We did meet that objective in how many tiger trout we're catching. However, the mean length was only 11.6. So small fish after 10 years of stocking. Another thing we looked at to determine why these fish may not be performing as expected is age. So how fast are these fish growing? And to do that, we looked at otoliths. So if you're not familiar, otoliths are an ear stone in the fish's inner ear. It's a calcified structure, and throughout time, the fish lays down material on that stone. So when we extract those from fish and cross-section them, they look like this, if you can see it. Those alternating bands equate to a year of growth, so we can age our fish based off of this. They are super tiny, and this is actually an example of one of our tiger trout otoliths, a 7-year-old fish, so these fish are pretty old in terms of a tiger trout surviving in that high elevation. So we looked at otoliths and ages across those 3 lakes. And there's a lot going on here, but ultimately, I want to point out that at age 3, here, the average tiger trout in Upper Silas and Smith Lakes is about 10 inches, while at Cow Lake, it's about 15 inches. So much faster growth at Cow Lake. And then again, at 7 years old, our average fish, 11 inches, 13 at Smith, and then we're getting up to 17 inches here. So you can just see that our fish at Cow Lake are growing much faster. I mean, Upper Silas here is almost turning into a flat line, and we did have a 9-year-old fish that was less than a foot long. So these fish just aren't quite growing in these 2 lakes as we had hoped. We also looked at diet data to determine if maybe that was affecting their growth. So we took stomachs from, I think we had about 75 samples. And I looked at those samples and identified all the items in those stomachs to the order that they belong to. So this is a figure with all 3 lakes combined. So that's something to note. There's 14 different orders that I identified across these samples. So up top, the order is here, percent occurrence is here, and again, some of these, like 6, 7 occurred in one stomach. So at the top we have true flies, so this was primarily your chironomids, but it did range from like a single mosquito to 200, 300 chironomids in a single stomach, particularly in Upper Silas and Smith Lakes. Plant material was common. Clams were only in Smith Lake, but that was just kind of an interesting find. weird thing that we found in those Smith Lake limits. Lots of other categories here, but the lake chub here is important. Those lake chub, 9 of the 10 samples that we had lake chub in were from Cow Lake. So most of our samples from Cow Lake, which has the fastest growth, appear have lake chub and appear to be taking advantage of that source, although again, it's a small sample size. You'll also notice that there are no longnose sucker, brook trout, or any other fish on here. So I did not find evidence of those tiger trout eating any other fish. And, you know, a lot of literature says that they are piscivorous, meaning they eat a lot of fish, and we just didn't see that in these higher elevation lakes. So there could be a lot of different things at play, but at this point, just to wrap things up and go over our conclusions here, for Cow Lake, our management goal was to create a quality tiger trout fishery. We ultimately did with our fish getting over 20 inches. Diet looks like they're eating lake chubs, and we're going to continue stocking biannually there, and hopefully we can get those fish back up to 20 inches without winter dipping. Smith Lake, we wanted to decrease that sucker abundance. Growth was really slow with a mean length of 12.4 inches, and diet was primarily of black invertebrates. We are no longer going to stock tiger trout in Smith Lake. In Upper Silas Lake, we wanted to change that brook trout abundance and increase size structure. Growth was the slowest here in this lake with a mean length of only 11.6. And again, aquatic invertebrates were the primary diet items for these fish. We are also discontinuing stocking tiger trout there. However, we'll continue to monitor them. It's possible that these fish just weren't big enough to eat the brook trout or the longnose sucker that are available to them. So maybe in 5 years, we'll go back, we'll have some tanks there. Maybe, we can hope. So we'll continue to monitor that, but instead of stocking at those lakes, we are now stocking tiger trout and have this past year in Fiddler's Lake, which is also on the Loop Road. Similar habitat to Cow Lake, a little bit bigger, so we hope that they do well there. I'm happy to answer any tiger trout questions, yes.
Did they compete with any other, with such a diverse diet? Do they compete with any other fish species for that diet?
Yeah, great question. So we did not look at other stomach samples, but lake trout and Smith Lake, in general, lake trout pursue a different niche than our tiger trout would. There does seem to be some overlap. Again, this is in the literature because we did not look at other fish in the system, but there does appear to be some overlap with Yellowstone cutthroat, so that's a possibility. I don't think, just based on this and based on the systems, that competition is the #1 thing that's causing our tiger trout not to grow, but it certainly is a possibility. Yes.
You mentioned management expectations. What drives management expectations?
Ooh, that's a big question. What drives management expectations? So, I would say I'm going to try to speak to tiger trout. I would say the public drives management expectations, what the public want to see, as well as how can we create, be creative as managers with fish. So I think driving management expectations for tiger trout looks like being able to make them desirable for people to catch and most useful for managers. So, for example, using them as biological controls like we try to do here. I think both of those things, kind of trying to find the balance between public and how we can make them useful in a system. So we're not just putting putting fish everywhere and hoping for the best. Does that help?
Yeah.
Yes.
Are lake trout native, and would you ever supplement fishery by stocking them?
Great question. Lake trout are native. Thanks, Paul. And there are actually lake trout in Smith Lake. So would we ever stock to supplement? Are there any hatcheries that produce lake trout? No, there are not. I don't know if producing more lake trout would necessarily change the outcome of our tiger trout. In these higher elevation lakes, I think it has a lot to do with the system and how productive it is. These higher elevation lakes, shorter growing seasons. We're just not sure how these fish necessarily perform up there. Like, we'd like to think they take all the best characteristics of a brown trout and a brook trout and make a super fish that can survive everywhere, but it's not necessarily true. So I'm not sure if that would make a difference, but I guess the answer is no. We would not stock them in these lakes. Any other questions? Yes.
Was an estimated winter kill for Dow Lake 100%?
Yes. Yeah, for tiger trout, the lake trout are fine.
Oh, great.
Yeah, the lake trout are great.
What made the tiger trout, like, just totally bite the dust?
What made the tiger trout bite the dust? Yeah, good question. They're a hybrid brown trout, brook trout. Brown trout tend to be pretty sensitive, both of them sensitive in certain ways, either to elevation, dissolved oxygen, different factors. So I think if you had put a brook trout, a brown trout, tiger trout, rainbow trout, I think everything in there would have died. Yeah, so I don't think it's like tiger trout died and if we had something else in there, like they actually survived better in there than brook trout did. So, any other questions? Yeah.
Are tiger trout like used for management anywhere else in Wyoming?
Anywhere else in Wyoming? They are also used many places in Wyoming, including Beaver if you want to catch a state record tiger trout. High Savory, Sunshine, quite a few other fisheries. Success there, I mean, obviously they're doing great in Beaver. That's a completely different system now, that's more like oyster. So I think other people in the state have had success with tiger trout elsewhere, but in higher elevations, still questionable. And it has been questionable in others and variable in other states as well. Yes.
Back to the winter kill issue,
Mhm.
is there a minimum depth where fish will be protected from winter kill, or does it just depend on that particular winter?
Yeah, so is there a depth where they would be protected? It definitely depends on quite a few factors, including like the dissolved oxygen levels, the temperature. Is there an outlet, an inlet? And again, like what those fish are, how old those fish are, how big those fish are, those all play roles, and how survival goes. I wouldn't say there's a definite depth where they'd be safe. Yeah, depends on elevation, ice cover is important, how long are they in a lower oxygen state?
So good ice cover. Good ice cover is better than less ice cover?
Good ice cover is better than less ice cover. So ice cover can be protective, but it can also cause more anoxic or lack of oxygen conditions. So not necessarily better, and depends on how long it's there too.
So it's quite variable then?
Yes, very.
From year to year?
Yes.
And with many factors?
Mhm. Yep. Yeah. Any other questions? Yes?
What was like the main environmental components that you can think of at least that like separate Cow Lake and Fiddlers versus Smith and Upper Silas for being like good environment for these guys?
Yeah, great question. So differences in environmental components at the lakes. So Cow Lake is our lowest in elevation, about 9,100, 95, 91. And Smith Lake is at about 97. Upper Silas is at 10,100. So speaking to that, like ice cover and all of those factors, water temperature, and overall productivity. So like I was saying earlier, in Cow Lake, you go out there, it's not pleasant to swim in because there's so much vegetation. Whereas in Smith Lake, it's got a really deep cut off of the shoreline. You can swim in it, not be like touching vegetation all the time. But that also means it's just not as productive. And that primary production, I think, definitely goes through multiple steps to get to our fish. So that productivity, I think, is definitely a big difference between those lakes and varies quite a bit with elevation. Yes?
How come the hybrids are sterile when other hybrids that we have in the mountains are?
Yeah, great question. So why are tiger trout sterile when others aren't is the question. So in the hatchery, our tiger trout all come from the hatchery. They are made to be triploid. So they actually have an extra set of chromosomes. And the hatchery does this by applying a lot of pressure at a certain time post-fertilization of the eggs. So basically those tiger trout have 3 sets of chromosomes. They're triploid instead of having 2. And that makes them relatively unsuccessful, if at all, in producing gametes. Yes?
Why do you do that?
Why do that? Great question. So why make them triploid? Making them triploid allows managers to put them in a space and know at any given time the maximum number of fish we're gonna have. So we know they're not gonna take off. We know that they're not gonna get out of hand. We can say at any given point, yeah, we know there's maximum, if they all lived, 600 fish in there, 600 tiger trout, and they can reproduce. So easy to control. Yeah. Cool. I will pass it back to Jake.
All right, change it up a little bit from trout. Lake Camille, so Bass Lake, this is out on the west shoreline of Boyson. We manage that one as a largemouth bass fishery, as the name suggests. We stocked bluegill about 10 years ago now. They've really taken off. Yellow perch were illegally introduced back in the 70s. Those things are everywhere, but the goal with bluegill was to try and create another forage base for largemouth bass. So last year, or 2 years ago now, I guess, we evaluated the bluegill population. There was a ton of them, pretty stunted, lots of small fish. So last year now, we did some nighttime electrofishing in the lake to evaluate largemouth bass diets. So like I said, the goal was to try and get bass to eat bluegill, create bigger bass, and balance out the size structure a little bit. So this was our way of trying to see if they were doing that, like we hoped. We do nighttime electrofishing because fish are generally more spread out in the lake at that point. They come into shallower water. Our electrofishing is not effective past a certain depth, especially in certain waters with high or low conductivity. So we try and target that nighttime when fish are shallower. So like I said, bluegill are highly abundant in there, and then to help facilitate largemouth bass eating bluegill, we placed a bunch of giant dead cottonwood tree structures around the shoreline in 2022 and 2023 and anchored those with large concrete blocks. Those are still floating now. The hope is that they'll waterlog, and we specifically targeted those areas to see if bass are eating bluegill in those spots. So, a lot going on here. This is just the raw number of bluegill that we captured on the vertical axis. This is their length on the horizontal. We use PSD as one of our metrics. That's proportional size distribution. So as the name suggests, it's the proportion of fish that in this case fall in the quality category, which is just an arbitrary fisheries management category to describe distributions of sizes. So the take home here is that we don't have a lot of big fish, like quality fish for bluegill, right? If you instead focus on this, we have a pile of small bluegill. So that's what we're trying to have bass eat. In a perfect world, this would be more of a bell curve. So we'd see a more even distribution of fish. It wouldn't be stacked necessarily one way or the other. So some cool results. That's a pretty good fish. This is 18 inches right here. So this was the first year we did a diet study in 2022 as well. No bluegill in the diets. This was the first year we had bluegill actually show up in largemouth bass diets, which was pretty cool. Honestly, the biggest diet item was crayfish, but the second biggest was artificial lures. So I'm not sure what to do with that one other than maybe people should secure their Senko worms to their hooks a little better. But no, it was cool. We saw bluegill show up in the diets, and more importantly, largemouth bass size structure shifted in the direction that we wanted it to. So before, we were actually starting to see a lot of big bass and hardly any small bass. And the theory was that they were kind of self-regulating, eating their young every year and preventing that recruitment. And with bluegill now showing up, we're actually seeing that shift a little bit left. So some smaller bass showing up and balancing things out a little bit, giving us more of that bell curve shape in the fishery. So some pretty cool stuff. We're going to try and repeat this same evaluation this fall, see how diets change throughout the summer season, and go from there. So some cool stuff going on at Lake Camille. Any questions on that one? Yeah?
Yes, so electrofishing depth, like is there a range where it's most successful, or just does it depend on case by case?
Yeah, so certainly case by case. Low conductivity is not going to help you out much. It's not going to get your field very deep. And high conductivity is actually, it's so conductive that it's going to connect the positive and negative of that field really quickly. So it also doesn't get as deep. So in Camille specifically, I'm effective to about 5 or 6 feet of depth. In other places, I might be effective to 7, 8, 9 feet. But in most of my waters, and Paul's waters for that matter, I think you'd be pretty darn lucky to shock fish past that 9 or 10 foot range.
So how do you know?
If you're successful?
I mean, well, obviously you get the fish, but how do you know where to put the depth of the equipment?
Yeah, so I'm not gonna lie to you, it's kind of trial and error. A lot of it, when we shock at Camille, for example, so we do it at night, we have giant LED light bars. Everyone that's camping at the lake hates us. But we shine it into the water, and you can see fish run out of the field. So if it's not getting to the bottom, you'll see a fish dart to the bottom and run along the bottom and away. So they can feel the electricity coming. It's like think about it like a wave. So they can feel that coming, and if it's not dialed in correctly, they'll intentionally avoid it. And that's kind of your cue of like, okay, I need to change something up to make sure I'm catching them. Yeah. Yeah.
It looks like you're about to switch to Ocean Lake, so I'm going to ask another level question, which is, it seems like the size distribution of the perch is more or less similar to what you're seeing with the bluegill. Do you have any idea why that remains to be the case?
Yeah, perch are a tough one in there. They're just so abundant that we don't have the mouths to even control them. We stock tiger muskie out in Camille as well. It was a one-time, that was 2017. Those fish are definitely pushing 50 inches now. And we cannot get those perch knocked back. And they do show up in largemouth bass diets. they're a part of it for sure. But yeah, we don't seem to have the numbers and the mouths to really control, to exceed the reproduction rate of yellow perch. And there's so many of them. I mean, this is a great plug if you guys have kids or first-time anglers that like to catch fish, or you want to get someone hooked on ice fishing for some sick reason. You can take them out to Camille Lake and catch a pile of perch. So, any other questions before we switch to Ocean Lake? Okay.
All right, now that we're talking about cool and warm water fish, so we're going to talk about the Ocean Lake fishery here a little bit. So Ocean Lake is a stocked walleye fishery. They can't really naturally reproduce because Ocean Lake is so silty and muddy, the eggs get suffocated. So we stock 320,000 fingerling walleye in Ocean Lake annually. Ocean Lake doesn't really grow big walleye like a place like Boyson. It's the maximum depth I've ever found is 26 feet. It gets really warm. It's not good for growing big walleye, but if you like, 17 to 20 inch fish, that's, like fish in these pictures right here. That's what you can really expect when you go to Ocean Lake. So this is results from our walleye netting. So we have year there on the horizontal axis, and we have our walleye catch rate on the horizontal axis. So that's the number of walleye we catch per hour of netting time. So for example, if we set a net for 10 hours and we catch 10 walleye, then that's 1 walleye an hour. So this 2024 was a really good year. Other than 2020, it was the highest walleye catch rate that we've had since we implemented our walleye monitoring strategy in 2008. 2020 was kind of a weird year. For some reason, all of our so many 2019 stocked fish survived. We had hundreds and hundreds of 9 to 10 inch 1-year-old walleye in our nets in 2020. And then you can see the population crashed in 21. What we think happened is they ate themselves out of house and home, and the population crashed. There were just too many fish. They starved to death. But population recovered fairly quickly after that, so pretty good walleye numbers in 2024. This is our age frequency, so you have age there on the horizontal axis, got cut off there, but and then the percent of walleye of each age. So we age these fish just like Caroline talked about, using otoliths. Lots of 1-year-old fish, 3-year-old fish, and then compared to most other years, we had a pretty good number of 5 to 8-year-old fish. Walleye don't really live super long in Ocean Lake. It's rare to find a fish over 10 years old versus like Boyson. I've aged plenty of fish over 20 years old. This is our size distribution. So let me go back there. So you have your length categories on the horizontal axis, the percent in each length category by inches on your vertical axis. So lots of 15-inch fish, and then we apply that to the fish that we aged. So your 15-inch fish were about 3 years old. Your 1-year-olds were about 9 to 11 inches. Your 2-year-olds were 12, 14. Once you get about 5 years and older, your age at size can vary a lot because your walleye are going to stop putting energy into growth. They're going to start putting more energy into reproducing. So there's just a lot of variability. You can get like, an 8-year-old 17-inch fish and a 5-year-old 15-inch fish. So lots of variability there, but pretty good numbers of 15-inch and bigger walleye, which is what people would like to catch to take home to eat. Ocean Lake's also known for yellow perch, and if you're a perch angler, you'll be happy because perch numbers were down for a while, but they increased quite a bit in 2024. In fact, the highest catch rate we've seen since 2008. Size distribution, lots of 7 to 9-inch fish. Not many 10-inch fish, but those perch are going to grow bigger in the next couple of years. And a lot of people like 10 inch is kind of like the standard for a lot of perch anglers, and I think in the next few years, we're gonna start seeing more 10-inch perch. Any questions on Ocean Lake, Andrea?
Yeah, before you move on, why the age discrepancy between Ocean and Boise? That's quite a gap.
It is. I think it's. I think water temperatures are too warm at Ocean Lake. It's a shallow lake. It gets really hot in the summer. It just doesn't get to the prime growing temperature for very long. And I think once those water temperatures get warmer in the summertime and they get warmer sooner than Boysen, those fish get stressed out. They lose weight. Yep. Anybody else?
Okay, Boysen rainbow trout. Contrary to popular belief, I believe Boysen is a trout fishery that supports walleye, not the other way around. All joking aside, we stock rainbow trout in Boysen. They do really well. It's a warmer water. We see fish live for about 3 years is all we get out of them, but they grow rapidly. So this fish is likely a 2-year-old fish in the reservoir, probably not even in its 3rd year, but it could be pushing its 3rd year. So one of the things that we hear a lot is stop stocking slimers. So we initiated kind of an in-person creel survey for the last 3 years that was conducted from April to July to see what kind of use people were getting out of the rainbow trout fishery there. So satisfaction was really high. It's 4.2 out of 5 across all the anglers that we interviewed. And the anglers are definitely targeting the spring spawn time. So they show up in April, May, fish it till early June when walleye fishing picks up, and then they go fish for walleye. So what's really cool about this though is that a lot of people are doing this from shore. You can see this picture of my friend here, just right down at Brandon Boat Ramp. You don't need a boat to get out and catch these fish, and they're really accessible in the spring. So like a lot of other waters in the state, it seems like people are starting to show up here to catch these spring rainbows at Boysen. So then we kind of follow up that netting or interrupt those creel surveys with standardized netting each May. And this is again to evaluate size structure. What we found from last year is that the 2022 cohort of fish is really, really strong in the reservoir and stealing the show. 2025 netting is still to come. But this is a really cool figure. So again, number of fish here, and then on the bottom here is going to be length. So we have our small fish, which would be, in this case, the 2023 cohort. 2022 cohort is in the middle under quality, and then 2021 cohort is under preferred here, okay? So this is mean size, and this is from anglers. This is what anglers are catching. So mean size is 18.7 inches, and then we've got fish up to about 25 inches here. But really a lot of those fish are right in that 16 to 20 inch range, and that's what anglers are catching. What's really cool is then when we look at our netting data, it's almost identical. So when we go net the reservoir, we have pretty high confidence in saying that what we see is what anglers are catching. And so our mean size was actually smaller, which is great. Anglers are catching bigger fish, makes sense, they're coming into shore to try and spawn. So it's really cool to see that, but like I said, this is that 2022 cohort of fish, and we see a lot of those. We don't see a ton of the 2023, and we don't see a ton of the 2021. We're not sure if some of these fish got stocked really early and walleye put a dent in them. We also know that in high water years, we lose quite a few fish over the spillway into the river below. Anglers tell me all the time that the best fishing in the river is when we have a high water year. So we know a lot of those fish get flushed over, but I think the take home from this figure is that our netting is fairly representative of what people are catching in the reservoir, and we grow some pretty awesome trout pretty quickly in Boysen. So one thing we do have going on is we stock 2 strains of trout in there. We stock fall rainbow trout and Eagle Lake rainbow trout. Both rainbows, just different strains. And starting with last year's stocking, we clipped the adipose fin on all the Eagle Lake fish. So starting next year, when those fish are kind of in this primary bin, we'll sort of resume some of those creel surveys and see how many of those fish that are coming back to anglers are clipped versus unclipped, so we can kind of hone in on which strain does best and continue to refine that stocking. So, and again, this is just kind of zooming in on those cohorts. We only see a few fish in this 2023 and 2021, but then a ton of those fish from 2022. So hopefully in 2025, all of these fish will be sitting in this category, and we see some of these fish show up here in this category. So everything's going to shift to the right until they hit their 3-year mark, and then we lose them. So, any questions on that one? Yeah.
What's a slimer?
A slimer is a term some people use for trout.
I've never
So,
heard that before.
a lot of people
No scales.
A lot of people love to use that one because we're human. We want what we can't have, right? And Wyoming's a trout state, and when we have a walleye fishery, we get a lot of questions on why the heck we're stocking more trout when we have one walleye fishery in the Lander region or two. But yeah, so it's a term that they use for that. Other questions? Yeah.
Do you know why the life expectancy is around 4 years in the lake? Like these people are invited to the Congress,
Yeah, so the question was if we know why there's differences in kind of that life expectancy or why it's shorter in the lake. So it's actually a really good comparison to what Caroline talked about. In those high elevation lakes, they're seeing tiger trout that are 9 years old, that are 12 inches, right? Those are high elevation, cold, clear waters. Boysen is the opposite of that in every sense. So typically, the relationship we see is warmer waters equals faster growth equals faster death. Whereas we have some higher lakes, clear, cold, we generally think colder water equals slower growth equals longer life. That's the general relationship. So Boysen they grow so fast. They're stocked at 8 inches. In technically a year and 8 months, they're 18 inches. And by 2 years and 8 months, they're 22 to 25 inches. They just grow so rapidly that we lose them.
Is that the same with River?
Sorry, what's
Is that
that?
the same with Wind River Canyon as well?
So Wind River Canyon's a little different. Boysen is extremely productive, but Wind River Canyon is just unbelievably productive. And riverine systems also tend to be a little bit different in that relationship than some of our reservoirs. So those fish conduct a lot of movements. They can exploit a lot of different habitats up and down that gradient. So I don't know the exact life expectancy in that stretch, but I would assume it's probably going to be a little bit longer than Boysen. Other questions? Otherwise, that's it for my slides. Paul's got one more, but thank you guys for having me. I appreciate it, and I'll be around if you have any other questions. So.
All right, thanks, Jake. Talking about fish living longer in colder water, higher elevation. We've actually aged lake trout over 50 years old up in the Smith drainage, and they're 8-9 pounds, so not huge ones. But there's another example for you for slow growth, longer life. So, well, this is it, I think, for the presentation. But Jake and Caroline and I have been talking a lot about sport fish, but thought we'd end the talk with we're also tasked with conserving non-game fish, especially those that are species of greatest conservation need. So this is a native fish project we have in the Sweetwater River. There's your 4 species that we're working on right now: horny-head chub, flathead chub, plains minnow, and common shiner. So a little bit of history about these species in the Sweetwater River is, so in the 1850s, the U.S. Department of War sent exploration parties out west to find the best railroad routes. They were tasked with collecting plant and animal samples for the Smithsonian. So a guy by the name of Solly Bowman collected fish in the Sweetwater River, as far as we know, It's the first scientific fish sampling in the history of the state. This was a long time ago, 10 years before the Civil War, 24 years before the Battle of the Little Bighorn. So I'm sure it wasn't easy for these guys, but pretty cool that they did it. So Solid Bowman brought these fish back to the Smithsonian. They were identified by Charles Gerard in 1856. So sometime between the 1850s and the 1930s, all 4 of those species on the previous slide disappeared. We don't know why, we don't know when, because the next fish sampling wasn't until the 1930s. We think we might know the causes. The Sweetwater River was heavily overused during Oregon Trail days, lots of overgrazing, lots of erosion. There was also gold mining that likely caused pollution, but at some point those 4 species became extirpated from the Sweetwater. All 4 of them I mentioned are rare species in the state and other drainages. So we started trying to reintroduce these species to the Sweetwater River. We started with horny-head chub because that's one of the rarest fish in the state. So we reintroduced horny-head chub in 2020 and 2021. We transplanted them from the Laramie River. And so far, they're surviving, they're reproducing. It's been a success so far. We're still not quite there yet, but so far results are promising. And we're comfortable enough with horny-head chub. We're moving to the next rare species, which is plains minnow. We're hoping to do a reintroduction either in 2026 or 2027. The only major drainage that exists right now in the state is the Powder River drainage. So we're going to start sampling this year in the Powder River drainage, both with the Sheridan and Casper fish management crews. We're going to make sure we can find a place where we can catch enough to transplant them to the Sweetwater. We also want to make sure we do it right. We're going to test for fish diseases, make sure we don't bring anything like that over, but I guess that's the end. If anybody has any questions. Andrea?
So with the 2017 State Wildlife Action Plan being updated currently, will those species still be included, and are other fish species going to be included as species of greatest conservation need?
Yeah, so if you're not familiar, Andrea asked about the State Wildlife Action Plan. So it's something that all the state wildlife agencies have to revise every 10 years, and it's basically, threatened endangered species in your state, and we go through different rankings of species. So Andrea asked if there's going to be any new species, any changes in rankings. So yeah, 10 years ago when we had our State Wildlife Action Plan, horny-head chub were I'd say one of the 3 rarest fish in the state. They had the ranking of 1, which is as low as you can go. We've created 2 more populations statewide. So now they're actually going to be upgraded to a 2. Plains minnow, on the other hand, have, I wouldn't say they declined. There are just some other drainages where we did not know if they existed or not. For example, like the Bighorn River, through like Laurel, Grable, Manderson, all that. They did, the Cody crew did a lot of work, did not find any plains minnows, so they're actually going to be downgraded from a 3 to a 2, which is another reason why they're a priority to move them to the Sweetwater.
The, earlier you mentioned whirling disease, Charlie. That's a neurologic disease? Or do they know what causes that whirl?
Yeah, so, boy. Do you know what motorcycle whirling disease? You can take a picture.
Yeah, so whirling disease is a prion, so it lives in the sediment. So if, let's say, an infected fish dies, that lives on right there. So it's a spore, for sake of example. So that can be passed on to another fish. Now, depending on the life stage of that fish, it may or may not have effects. If it's an adult, oftentimes they might push through it. If it's a juvenile, it will nest, increase in abundance in their body through time, and then it actually starts to, more or less, it's the fish equivalent of a human neurological disorder. So it will basically create almost like CWD, where they start to swim in circles and lose that ability to do it. But we also see physical effects in especially juvenile fish, where their tail and spinal structurally deformed. So you can see like a black tail on fish, or you can see waves in some of that, like a scoliosis kind of equivalent. So does that answer your question?
Well, yeah, I didn't realize how much they knew about that it was a prion disease. Is it similar to what we can get, like mad cows with prion disease or some of those?
In a way, reaching a little bit, but yeah, I mean, more or less. And it just, the problem is that it persists in the environment. And so if we ever wanted to like get rid of it in a system, we'd have to clear that system out of fish, let it sit for a while to clear the prion out since it doesn't have a host, and then restart.
Thanks.
So what is the host in it? How does it continue on from waterway to waterway?
Yeah, so the vector, I don't know that. That's a great question. By thinking through it in terms of reason, I could see a lot of situations where you maybe have a bird move a fish, and that fish ends up in there dead and spreads those spores. Another big one is anglers and wading boots, and that was a big push of felt soles a long time ago, was that tracking mud and tracking things like that can actually spread those things. But birds are a big vector for a lot of things. Lake Camilo has swimmer's itch parasite. That came from bird lakes. They landed in there and the parasite spread. So I'm not 100% on all the vectors, but those are a couple that certainly could be at play. Yeah, that's so the tube effects worms is like the name of the actual like parasite, if you will. So those are the tube effects worms are going to be the things living in the sediment that are going to be spreading and propagating that. Yeah.
If it is a situation of like on the bottom of boots, washing them does the trick as far as not spreading invasive?
Yeah, so we have the whole clean, drain, dry thing with the state. So yeah, generally the common guidance on wading boots is, there's a few options. There's 140-degree water for a fixed duration of time. I'd have to get back to you on that. Embarrassingly, I don't know the duration. Freezing them is another one. 30 days of non-use is kind of the third one. So between those three, ideally, if you can do one of those between waters, that would be ideal.
Between waters isn't like say you go from the wood photograph to the middle photograph.
So good question. I am hypersensitive to things like that, so I'm going to tell you between every water. That guidance changes based on people. I think there's a lot of guidance that as long as you're within drainage, and ideally not moving from lower drainage to upper drainage, you are in theory better off, but I'm going to tell people, and I do tell people, to just do it between waters.
So what about wading boots that have rubber soles? That's the...
Yeah, so rubber sole, that's where we went after felt. So rubber soles are a lot better because they just don't saturate with things like that, and they're not as hard to decon. We can decontaminate. So like when we get back from a sampling event, we turn our Hotsie on, it's 140-degree water. It just, you can watch the mud fall out of it, right? Out of each little tread pattern. Whereas the felt, you've really got to sit there and saturate it and hope that that 1.5-inch layer of felt is all getting exposed to that water.
What about direct sunlight on felt? Like you set it out in the sun for a period of time?
Yeah, so it's a duration thing with that. So can certainly do it, but it's that 30-day guidance of no use. So and we apply that to not just wading boots, but boats. If we have a boat that's been out of the water for an extended period of time, we perceive that as less risk than something that's been in the water recently. Yeah.
Yeah, Paul or Jay, the lake trout population wins, all naturally reproducing, and any of those lake relic populations.
So Alec asked if the lake trout in the Wind River Range are naturally reproducing and if they're glacial relic native species. So they do naturally reproduce. So they're not native to Wyoming. So all the lake trout are not native. They were introduced through stocking, but They're like one-time stocking events, and they've been naturally reproducing ever since.
So what trout species are native to Wyoming?
Andrea asked what trout species are native to Wyoming. Cutthroat trout.
That's it? And all the strains, Yellowstone. Like,
Yeah.
That's the cut slam, right?
Yeah, so you have, it gets complicated because they just revised cutthroat species and subspecies, but I'll just go by our cut slam. So cutthroat trout is the species, and then Wyoming, if you include extirpated species and species that live in Yellowstone National Park, actually had 6 subspecies. West Low cutthroat is the species that lives in Yellowstone. Greenback cutthroat is a species from the South Platte Drainage that's extirpated. But our cut slam, the 4 subspecies are Yellowstone cutthroat trout, Snake River cutthroat trout, Bear River cutthroat trout, and Colorado River cutthroat trout. So 6 species originally in the state borders, I guess now 5. James.
So, you guys saw a little closure, you saw a lot of hooking injuries, did you see a lot of handling injuries or anything like that? Because you can see like thumbprints and stuff like that on the back of some fish that have like black roots, so like almost like a thumb like that.
I guess speaking for myself, I rarely see handling injuries. I see hooking injuries, sure, and actually a little Poja had a really low hooking injury rate. 93% of the fish had no hooking injuries, but I don't know, do you have anything to add about handling?
Yeah, I was just gonna say, as a side note, if you guys happen to be fishing one of those spots after we've electrofished it, you may see some fish with little black spots or discoloration on their skin. That's often a side effect of electrofishing. We try to avoid it. It inevitably happens to a few fish. So if you ever see that, we may have been shocking there fairly recently.
And on top of the black spots that are from electrofishing that Jake mentioned, when we do bigger waters, say like when we do the North Fork Poja this fall, there's too many fish in there for us to do a depletion estimate to take all those fish and pull them in live cages. So instead we do what's called a mark recapture estimate, where we will take little fin clips off of different fins, so that when we catch those fish the next day, we'll know, like, you know, everything we caught on the first day, we'll take a little clip out of the lower caudal, second day upper caudal. So that's another thing, like, if we've been electrofishing, you might see little fin clips on fins.
I've fished the brookies in the old vine bowl up at South Pass, and they looked really healthy. Small heads, big bodies, they seemed to be real healthy, but they were incredibly slimy. Like they had been sliming out, talking about slimers, but they actually had a lot of slime. And my understanding is that part of that slime is a protective mechanism, and that is there something there that's disturbing them, like the asbestos that's in the line hole, or something that would cause them to be so slimy with that?
You know, I honestly don't have a good answer to that. I guess I could say that, you know, that's an entirely private lake there, so,
You guys probably don't test that.
we don't manage it. It's, you know, if you want to fish there, you gotta have permission. So I guess I can't speak to any type of, contaminants.
You haven't seen that in other lakes. I have permission. I wasn't poaching. But I threw it back because I just had a suspicion that maybe I didn't want to be eaten.
Yeah, you know, I guess we haven't tested those, and that's actually the responsibility of the Department of Health, but I highly doubt they're gonna test fish in private water that the public doesn't have access to. You know, we'll get samples for the Department of Health from public waters, but.
Well, they do run down Rock Creek, so I would imagine, I don't know what they're like down public.
We haven't tested the fish in Rock Creek either, that I know of.
Follow up on my management
expectations, if you achieve all the metrics you want, does that also basically indicate that the lake is healthy and the riparian area is healthy?
That, I guess, do you have a, like, you could have all kinds of different management expectations or goals. I guess it just depends by water. You know, riparian area is important on a stream, but like, it's not on moist, you know what I mean? So, do you have like more specific water to have a question about, or, I guess I'm having a hard time answering your question. I don't exactly
Water in
know.
general.
Okay.
I'll add something to that. So a lot of times with our management expectations, you know, Paul and I are fish biologists, so we really focus on the fish. And, you know, we're fortunate in the department, we have a lot of different roles. Like Carly right here is our aquatic habitat biologist for the Lander region. And so we're disjunct in the sense that we each kind of focus on a different component. And then we kind of work together to try and address any specific one that might come up short, if that makes sense. So the one thing I'll caveat that with is that if it meets management objective, generally we're good with that. We say it meets management objective, great. If